Welcome, geometry students, to the Chapter 2 review packet as we prepare for our quiz if you're one of my students covering these lessons, 2.1 to 2.3, and then a little bit from 2.8. So let's jump right into it here. Here you'll see me go through the problems step by step. Please, as always with these, try these problems yourself first as best as you possibly can. Treat this like a practice quiz, this chapter review, and then just come to here and just check out the ones that you need help on. If you want to watch the whole thing just to get my explanation on it, even if you did do the whole packet or most of it, then you're totally welcome to do that, of course. But don't just copy the stuff down you see here. Really, the quiz grade is what matters the most, and doing this as a practice quiz and then coming here after you've tried it yourself is really your best bet. So, example 1 or number 1, we're trying to determine if the conjecture is always true or false. And if it is false, we need to provide a counterexample. So let's say we are given this. ST and U are collinear, and ST equals TU. So our conjecture is that T then has to be the midpoint of segment SU. So if they are collinear, I know they lie on the same line. I am going to just, why don't I get out my line tool. Make a little better line like that. Keep stuff in blue though, okay. So collinear, they're either on the same line or same segment, something like that. And I'm going to say that this is S, and it says ST and U are collinear, so on the same line here. And ST equals TU. For the only way for that to happen is if T is right in the middle. You couldn't have T over here and then U here, because then ST from there to there would not equal TU. It wouldn't be the same length. If they're collinear, they have to be on the same line like they are here, and since they're equal, I could put a tick mark here and here. So based on what I have there in the picture, this was the only way I could draw something based on the given information up here. Does T then have to necessarily be the midpoint of SU? Yes, there's no way around that. This one is true. There's no way to draw a counterexample making this first part true, but the second part false. Number 2, given angle 1 and angle 2 are adjacent angles, the conjecture is that they have to form a linear pair. So if they're adjacent, that means they have a side in common. Maybe something like this and this. But notice, I just drew a pair of adjacent angles. If I label this a 1 and a 2, this is a pair of adjacent angles. They've got this ray in common right here, this side in common. However, they do not form a linear pair. This is a counterexample. This is why this one is false. You could draw other counterexamples where these angles are slightly bigger or smaller, but they don't form a perfectly straight line together. So this one, we came up with a counterexample proving that conjecture to be false. Number 3, given points A, B, and C are collinear, the conjecture is that AB plus BC equals AC. That's always true, only given this information. So let's draw another line here, or another segment in here, so something like this once again. Now if I have A, B, C are collinear, I can put them anywhere in the line. It doesn't say something like it did up here that A, B has to equal B, C, anything like that. So I could put, why don't I say, I'll put A here, I'll put B here at the end, and I'll put C right about here. So if I add AB, the whole thing, plus BC, this little part, does the whole thing plus this little part equal this thing? No, you could say the whole thing minus this little part equals this thing, but this is a counterexample proving this to be false. Just because the 3 points are collinear does not mean that this has to be true. If I said this and B was between A and C, then this would have to be true. However, it doesn't say that, so this one is false. I just came up with a counterexample showing that doesn't always have to work that way, only given this information. Number 4, A and B are complementary. Does that mean the measure of angle A has to be 45? Well, I hope this one's pretty clear. I think this one might be the clearest of all of them. Just because two angles add up to 90, that doesn't mean that one has to be 45. This one, for instance, if I called this A, this point right here, and maybe this I'm going to call B, this one could be 30 degrees, and this one could be 60 degrees. These are complementary, so the first part's true, but the second part is false. When we have first part true, hypothesis being true, the conclusion, our conjecture in this case being false, this is a false conjecture. That means we came up with a counterexample. This is false. It could be, anything but 45 between 0 and 90, and then the other one added to whatever number you picked has to add to 90, just like 30 and 60 add to 90, but 30 does not equal 45. I could have went with 25 and 65. I could have went with 20 and 70. I could have went with 89 and 1. All those things would be counterexamples. Let's check out the next one. So make a conjecture. The next set of problems follow these directions. Make a conjecture about the next item in the sequence. So it looks like here, the conjecture I would say is you're multiplying by 3 every time, times 3, times 3, times 3. So if I do that one more time, times 3, I would get 81. You could also say these are the powers of 3, 3 to the 0 power, 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. On this one, it looks like 1, that's the same thing as 5 over 5. And so to me, it looks like, thinking about that then, that we're just adding 1 to the numerator each time. So plus 1, plus 1, plus 1. The next one then would have to be 9/5. On this next one, it looks like we are dividing by 2. So divide by 2, divide by 2. That pattern continues. Divide by 2, divide by 2. 0.75, if we keep this in the decimal format that we see here, 0.75 divided by 2 is going to be 0.375. That would be my answer for that one. This one, it looks like we're going from light to dark, but the same shape, and then light to dark, same shape, light to dark, same shape. So keep that pattern going. We're just adding a side each time. So 3 sides, 4 sides, 5 sides, now 6 sides, light hexagon, and then the same shape, dark hexagon, so I was shaded in. Those would be my next 2 in the sequence. And then number 9, got a triangle. That same triangle and another one added there. Same triangle, so we took the same shape from the previous term in the sequence, added another triangle. So I'm going to do the same thing with the next one. Same shape as in the previous term. And then I'm going to add this extra triangle right here in this one. So on that would be my next thing in the sequence. They're kind of saying like this is one item in the sequence here. This is a second. This is a third. If you would just put that, I probably wouldn't mark you wrong because that would be the next item in the sequence. So on this one, I just included the next 2 items in the sequence. Number 10 now. We're going to get into the logic stuff at this point, less conjectures, more of the logic things that we've learned. Use the following statements to write a compound statement for each, then find its truth value. So let's do what we did here in class. If you're one of my students, let's talk about the truth value of each one of these first. Is it true that -3 minus 2 equals -5? Yes, that is a true statement. Is it true that vertical angles are adjacent? We think of vertical angles, that would be like this one and this one. Those are not adjacent. They don't have a side in common. This is a false statement. A hexagon has 6 sides. That's the definition of a hexagon right there. It's a polygon with 6 sides, so that's a true statement. And the sum of the measures of supplementary angles is 180. It's not 90 like it says here. So this is a false statement. So this should be 180 degrees instead if that were to be a true statement. So we know this is true, false, true, false. So now we're going to use that symbolism that we learned to write out a compound statement and then find the truth value. So remember, think of capital A, kind of looks like and. So this is like a capital A without the horizontal bar. This is and, this is or, and this is and. And so we have, let me just write out the statements, P and S. So this would be -3 minus 2 equals -5. And statement S is the sum of the measures of supplementary angles. I'll abbreviate that like this for now, is 90 degrees. That's just my angle symbol with an S to make it plural. So is this a true or false statement altogether? I think it's easiest to look at the statement in symbols to determine that. So P was a true statement up here, and S was a false statement. So if you have true and false, for an and statement, a conjunction to be true, both statements have to be true, or all statements have to be true. That means this one is false. This is a false compound statement. Just because one of the parts is true doesn't mean that the whole compound statement is true. Everything has to be true for that to be the case. This next one, Q, or not R. How would we write that? Q is vertical angles are adjacent. And then the word or for the kind of V-looking symbol right there. Vertical angles are adjacent or not R. So not R, we're going to say a hexagon does not have 6 sides. A hexagon does not, doesn't also works, does not have 6 sides. So Q is a false statement. I'll put an F there. And then not R, since R is true, not R would have to be false. With disjunctions like this, with ors in between, you only have to have one of the statements being true for the whole thing to be true. However, neither one are, so this one is false as well. Moving on to number 12, we have S, or not Q. S is this, so let's write it out again. The sum of the measures of supplementary angles is 90, or, and then not Q. Q is vertical angles are adjacent. Not Q would be vertical angles are not adjacent. So, or vertical angles are not or aren't adjacent. And so considering the truth values of S and not Q, S would be false. Not Q, since Q is false, not Q would be true. With disjunctions like this, you only have to have one being true for the whole statement to be true. So this one, we finally got our first true compound statement. And then number 13, R and not S. R is a hexagon, has 6 sides, so I'll write that out first. The hexagon has 6 sides. And then not S, so the sum of the measures of supplementary angles is not 90 degrees. The sum of the measures of supplementary angles is not or isn't 90 degrees. And we know that R is a true statement, and we know since S is a false statement, not S would be a true statement. This is a conjunction. You've got and in between, so all the statements have to be true for the compound statement itself to be true. In that case, or in this case, that is the case. We have everything being true. That means the compound statement is also true. Moving on to number 14 then. For the following conditional statements, identify the hypothesis, conclusion, converse, inverse, and contrapositive, and then tell which statements are true or false. If false, give a counterexample. So got a lot to do on this one. Let's first determine, let's just go in order here. So I identify the hypothesis and conclusion, and then converse, inverse, contrapositive. So on this, the hypothesis, that's the part after the if statement. It doesn't include the word if, but it includes everything after that. This is the hypothesis. And then you live in California, the part after the then. I could put, since I use boxes for final answers, let's make that a box. This is a final answer for my hypothesis and conclusion. The conclusion is that you live in California. So that's my original or conditional statement. And then I'm trying to do converse, inverse, and contrapositive from there. So converse, think of switching shoes to Converse brand shoes. We're going to switch our shoes to Converse. We're going to switch the statements in the converse statement. So if you live in California, then you live in San Diego. The inverse will determine the truth value of these statements in just a moment. So I'll leave a little space underneath this. I'm just going to write out the statements initially first. So the inverse, we negate. We take the original statement, the original conditional statement, the original if-then statement, in other words, and we just put nots in there. So if you live in San Diego would become if you don't live in San Diego, or if you do not live in San Diego. So we make that grammatically correct. If you don't live in San Diego, then you don't live in California. And finally, the contrapositive, we'll get back to those truth values in just a moment, but we'll just write the statements out first. The contrapositive, we switch and negate. It sounds the most complicated, and so it is the most complicated. It kind of matches up nice like that. We would have the contrapositive being that if you don't live in California, we got to switch it. So I'm going to take the converse and put nots in there. So if you don't live in California, then you don't live in San Diego. So if you don't live in California, then you don't live in San Diego. Now back to the truth values of these. And we're trying to, if it's false, come up with a counterexample. So the converse, if you live in California, then you live in San Diego. Is that a true statement or is that a false statement? If you live in California, does that necessarily mean, in other words, that you have to live in San Diego? No, there's, I don't know, like 35, 40 million people in California last time I checked. And not all of those people live in San Diego. You could live, so I'm going to say this is false for sure. And a counterexample would be that you could live, well, pick your city. Los Angeles, San Francisco, you could live Palmdale, where I used to live. You could live in, I'll say, San Francisco. I laugh a little bit at Palmdale because I doubt you know where that is. But look it up on the map. That's where I used to live. Don't live there anymore, though. So you could live in San Francisco. If you don't live in San Diego, inverse now. So let's pretend you don't live in San Diego. Then you don't live in California. Does that have to be true? Same thing. Converse, inverse. These are logically equivalent statements. So really, they're saying the same thing in a different way. This is also false. If the converse is false, the inverse is also going to be false. And for the same reason, we could pick the same city if we wanted to. You could live in San Francisco. You could live in whatever California city that's not San Diego and have this be a counterexample. So I'll say San Francisco once again. We'll just stick with that one. So you could live in San Francisco or San Fran. So there's a counterexample once again. And yes, you could live in Palmdale as well. That'd be a counterexample. If you don't live in California, contrapositive, then you don't live in San Diego. So if you don't live in California, okay, pick another state. We'll say we're living in the United States, but just not in California. Let's say we live in my state of birth, near and dear to my heart, Michigan. So let's pretend you live in Michigan. Does that mean you don't live in San Diego? Sure does. This was a true statement up here. We're assuming that San Diego means San Diego, California, and not some other San Diego and that's really obscure in some other state that nobody's ever heard of. So we're assuming San Diego, California. So if you live in another state, you can't live in San Diego if that's the case. So this is true. This initial statement up here would also be true. And notice this one and this one match the conditional and the original conditional and the contrapositive. Those we talked about being logically equivalent in class. They would have to be the same. Now let's check out number 15. So if two angles are vertical angles, then the angles are congruent. Same instructions for this one. So I'm going to box this in here. Two angles are vertical angles. That would be my hypothesis, part after the if. Then the angles are congruent. The angles are congruent is going to be my conclusion. The part after the then. And from there, let's do the same thing as before. Converse, inverse, contrapositive. Just because they're written this order here doesn't mean they'll necessarily be in that order on the quiz or test that you're taking on this. So just make sure you got those straight in your head, and you can get them no matter what order it would be written in. So converse, inverse, contrapositive. Converse, we switch the statements once again. So if the angles no, I shouldn't say the, because I don't really, grammatically that's not right to say it or to start it like that. So I could say if two angles, because that's what we're referring to at the start here. So if two angles are congruent. Now I've referred to what I'm talking about, two angles. Now I can say then they or the angles are vertical angles. I'll go with they. It's shorter. Then they are vertical angles. So that's just the statement, not saying that's true or false yet. The inverse, we're going to put nots in there in a grammatically correct way. So go back to the original. If two angles aren't vertical angles or are not vertical angles, then they aren't congruent or are not congruent. And finally, the contrapositive, we switch and negate. And so we're going to I could take the inverse and switch those statements, or I could take the converse and put nots in there. I'll go with that. So I'm going to say take the converse and just put nots in there. If two angles aren't congruent or are not congruent, then they are not vertical angles. So true false time now. The initial statement here, if two angles are vertical angles, then the angles are congruent. Yes, that's the vertical angles theorem, or that's a property of vertical angles. We know that these are congruent. That would be a true statement. So I should be able to go down to the contrapositive. Why don't I do that? These are supposed to be logically equivalent, and I should be able to say the same thing. So if two angles are not congruent, okay, got any two angles, they aren't congruent, then they are not vertical angles. So if they're not congruent, by definition of what vertical angles are, by the theorem that describes them, they can't be vertical angles either. So this one would also be true, meaning these two are in fact logically equivalent like we thought they should be. Now the converse inverse. Let's see if this changes at all when we do those. If two angles are congruent, then they are vertical angles. Does that always have to be true? Just because angles are congruent, does that mean they have to be vertical angles? No, it could be angles that are totally separate from each other. This would be false. So you could have an angle like this. Maybe this is 90 degrees. And then you could have another angle that's also 90 degrees. Notice these are not vertical angles, but they are congruent. So the first part was true. You came up with two angles that are congruent, but the second part was false. That means you found a counterexample. Inverse, if two angles are not vertical angles, then they are not congruent. Well, the same thing applies here. This is going to be false as well. You could come up with, I could use the same counterexample if I wanted to. Why don't I just come up with a different looking one just so you see another one. So I could say that these two would be an example of something that doesn't work. So two angles are not vertical angles. These are not vertical angles, this one and this one, but I'm saying that they are congruent. Why don't I go with 70 degrees and 70 degrees right here. So those two being congruent, but they're not, these two are congruent, but they're not vertical angles. So another counterexample. Both of these counterexamples would work for the other one as well. Let's move on to numbers 16, 17, and 18. These ones are like what you saw in 2.8. We're trying to find the measure of each numbered angle. Given that the measure of angle 1 is 54, why don't I write that in here? This is 54 degrees. Show me your work, show me your steps, show me that you know where these things come from. Measure of angle 2 would have to be 180 minus that, because you have a linear pair right here. So 180 minus 54. If I were to give a justification for my statement there, I could say that was by the fact that they're a linear pair. That means the measure of angle 2 would be 180 minus 54, which is 126. So 126 degrees. And the measure of angle 3, you could either do the same thing again. If this is 126 degrees, so I'm going to write that in a different color. I just proved that was true. That was something new I just found out. I could say this again, 180 minus 54. It's going to give me, or minus 126 actually is going to give me 54 by being a linear pair. Or I could say 54 is going to be the same as this one over here. 1 and 3 are the same because they're vertical angles. So I could use a couple different reasons there if I had to justify what I was saying. So the measure of angle 3, also 54. It says find the measure of each numbered angle. Measure of angle 1 was given to us, so I'll just box that in over there. There's part of my answer, 54 degrees right there. Number 17, measure of angle 3 is x plus 50. I will write that in the picture. The measure of angle 4 is 3x minus 20. These are vertical angles, meaning that they're congruent to each other. So I can say that then 3x minus 20 would have to equal x plus 50. If I had to give a reason, it'd be easy to do. Vertical angles would be my reason. Then I'm going to get x by itself, solve for x. I think this is the easiest way to go about doing that. You've got the x is going to cancel here and here, the 20s here and here. 2x equals 70 divided by 2. And that gives you that x equals 35. Not a final answer. This is important though. I'm going to use that now to determine the measure of angle 3. Plug it in right into this. Plug it in for 4 right into that. So measure of angle 3, you've got 35 plus 50. That means the measure of angle 3 equals 85 degrees. And the measure of angle 4, seeing that they're vertical, should be the same thing if I did this right. So that's a good way to check my solution here in the end. Excuse me. So 3 times 35 minus 20. 3 times 35 is 105. And 105 minus 20, that works out. That's 85 degrees. So that means the measure of angle 4, like we expected, is the same thing, 85 degrees. So I plugged in 35 here, I plugged in 35 here, and got that. 5 and 6 in this one. 5 is 10x plus 28. 6 is 12x minus 24. And here looks like 5 and 6 make a linear pair together. So you could say that 10x plus 28 plus 12x minus 24 would have to be 180 degrees. The reason for that, they form a linear pair. So from there, combine like terms, 22x for the 10 and 12x. 28 minus 24 would be a positive 4 equals 180. You can subtract 4 from both sides. That leaves you with 22x equals 176. And if you divide if you divide 176 by 22, we should get a nice clean whole number. It ends up working out that way. X equals 8 in this case. So I'm going to take that piece of information, plug it in into what I see here and here to actually find the measure of each numbered angle. This isn't your final answer, but you're real close now. So I'm going to take this. I know the measure of angle 5 is 10 times x, 10 times 8, then in other words, plus 28. And that would be 80 plus 28, which would be 108 degrees. And the measure of angle 6 would be 12 times that, 12 times 8, minus 24. 12 times 8, it's 96. 96 minus 24 is 72 degrees. And if I take this one and this one, add them together, I should get 180. I do. That makes sense though because I have a linear pair there. So that's what I started with. Plugging these values back in, or plugging x back in into the initial equation up here would give me a true statement. Now it's time to finish it up with the big daddy, the truth table. All right, so make a truth table that describes the following scenario. We have three different statements, three different base statements, P, Q, and R. Q is a not Q in the final statement. Let's make our truth table. So let's make some columns first of all. I see P, Q, and R. I'm going to make three smaller columns to start. And I'll try to make those relatively the same size. There we go. And then I have not Q. So I'm going to say that this is my first column here. This is going to be P. This one will be Q. This one will be R. I'm going to need to find what not Q is. So I'll put not Q there. And then I need to do this before I do the whole thing. Just like order of operations in math, you do parentheses first, or in arithmetic, you do parentheses first. Just like that in logic, we also do parentheses first. So the next statement I would have would be P or R. And then from there, I would have the entire statement to finish it up. So not Q and P or R. So let's figure out what I got here first. I'm going to use orange just to, nope. I'm going to make some lines across just to make sure it's easy to follow my work here. So there's three. I'm going to need four trues and then four falses, and then two trues, two falses, two trues, two falses, and then alternate. So I'm going to need 8 different rows here. I got 1, 2, 3, 4, 5, 6, 7, and this will be my last one down here. I'll just bring that up a little bit here. There we go. That should do it for us. And so we have true, 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 true. Let's start with that. And then the other ones could be false, 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 false. This one we alternate every 2. So true, true, false, false. The way I'm doing this guarantees that I'll get all different possibilities, all different 8 combinations for P, Q, and R. And then I alternate every 1 for the last one, true, false, true, false, true, false, true, and false. So for not Q, I'm going to take the Q column here. Excuse me, what was that about? I don't know, the Q column, and I'm going to take the values and negate them. Do the opposite of what I see. So true, true becomes false, false. False, false becomes true, true. This would be false and false. This would be true and true. P or R, I'm going to take this one and this one to give me that column right here. So look at these ones together with these ones. I'm going to highlight that just to make it even easier to follow along, I hope. So I'm looking at this one. Let me make that a little bigger. Yeah, there we go. I'm looking at this one and this one to determine this column right now. So I've got for or, I just have to have one of these being true. This is P or R. So as long as one of them is true, the statement itself, compound statement, is true. So that would be true. True, false would be true. True, true would be true. True, false, another true. False, true, at least one true still, so that's true. Here's our first false. We've got 2 falses. That means the disjunction, the or, is false. We've got 1 true here, so that's true, and then we have a false here. So now I'm going to take my highlighted stuff there. Let's get rid of that. Whoa, not the whole thing. You know what, I'll just use a different color here. So I'll highlight, I'll go with green now. I'm taking not Q and this statement, P or R, putting that together with and, with a conjunction. So I'm going to take this now in green. This one right here, I'm going to take those two and finish up right here with my final statement. Wow, the final statement is going to be right there. So this is going to be for and both of these things have to be true. This and this have to be true for the conjunction to be true. This one, they're not both true, so it's false. Same thing here. Here's one where they're both true. This one's true. Same thing here. And then down here in the next two are going to be false. They're not both true. Here's another both true. And then here's one where they're not both true once again. This is my final answer right here. This is my final truth value column. So that's the truth table that describes this situation. Given any statements P, Q, and R, these are all the possible combinations that you could have for those yielding not Q and P or R in the end. So that does it for this review packet. That's it, all done. Go back though if you need to and check out any of those problems again if you found that helpful. And feel free to like or leave a comment just saying that you did. If you found any mistakes, especially if you're one of my students, let me know. I'll give you some Wagner bucks for finding that mistake. Make sure you comment the time that you saw the mistake and what the mistake was, if that is what you're going to do. All right. Hope you have a good rest of your day. I did double check all my answers, so I think should have all been good there. But again, if you found any mistakes, let me know. Have a great day. I'll catch you later for the next lesson.